Alright, hello. So in today's video, I'm going to be going over the derivatives of the 6 trigonometric functions. So sine, cosine, tangent, cotangent, secant, and cosecant. I'm going to start with sine, cosine. So let's get into it. So first, before I introduce the sine, cosine derivatives, I want to kind of give some intuition for why they are what they are. So let's draw sine. So sine looks something like that. It's a pretty rough sketch. So has a 0 at pi, and 2 pi. And we know it has a local maximum at pi over 2, local minimum at 3 pi over 2. So that is what sine looks like. So if we're thinking of what the derivative of sine should be like, we know that its derivative here at this highest point, we know that slope is going to be 0. So we know the derivative function should have zeros at both the places where it's at its highest point. We also can see that its derivative, it's kind of hard to see based on the picture, its derivative is at its highest at 0 and at 2 pi, and it's at its lowest at pi. So if you did this for every point where you found the slope, the instantaneous rate of change at every point, and you graphed it, you get something that looks like this. Now, to me at least, that looks an awful lot like cosine. And that's because the derivative of sine of x is cosine of x. And somewhat similarly, you could do a similar process with cosine. You can get some intuition that the derivative of cosine of x is minus sine of x. Okay. Alright, so now I'm going to go over the derivatives of secant and cosecant. So similar to... Alright, so now I'm going to go over the derivatives of secant and cosecant. So similar to for the derivatives of sine and cosine, I'm not just going to say them outright. I'm going to go over some intuition for why they are what they are. So the derivative of secant, the same thing as the derivative of cosine of x to negative 1 power, because it's the reciprocal, right? So using our chain rule, our outside function is x to the negative 1. Our inside function is cosine of x. We do the derivative of the outside evaluated at the inside. That's negative 1 times something to negative 2. Now, the something is our inside function. So, our inside function is cosine of x. Now, that's being raised to the negative 2 power. Now, the derivative of the inside is minus sine of x, because cosine differentiates to minus sine. Now, these minuses will cancel. So this negative 1 power means a reciprocal. So 1 over cosine squared of x times sine of x. So the way you'll often see this be written is we'll split up this cosine. So this is the same thing as 1 over cosine of x times sine of x over cosine of x. So this is secant of x, and this is tangent of x. So all in all, our derivative is going to be secant of x times tangent of x. Okay. So that is the derivative of secant. Now what about cosecant? Cosecant is the reciprocal of sine. So we want to know the derivative of sine of x to negative 1. So, again, this is going to be negative 1 times the inside to the negative 2 times the derivative of the inside, which is cosine of x. So this is negative, and then sine of the negative 2, that's 1 over sine squared times cosine of x. So again, we're going to split this up. So this is negative 1 over sine of x times cosine of x over sine of x. So this is cosecant of x. This is cotangent of x. So all in all, our derivative is minus cosecant of x times cotangent of x. Alright, now I'm going to go over the derivatives of tangent and cotangent. So, the derivative of tangent, that's going to be the derivative of sine of x over cosine of x. So we can actually use our quotient rule for this. So this is going to be the derivative of sine of x times cosine x minus sine of x times the derivative of cosine of x, all divided by cosine squared of x. Basically what I did was I did derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. So derivative of sine we know is cosine. So this becomes cosine times cosine is cosine squared of x. Minus, we know cosine differentiates to minus sine. So this becomes sine squared and the minus cancel. So plus sine squared of x, all divided by cosine squared of x. Okay, so we can split this. Cosine squared plus sine squared, all over cosine squared, that's cosine squared of x over cosine squared x plus sine squared x over cosine squared x. So this becomes 1 plus, and then sine squared over cosine squared, that's tangent squared, x. And using identity, we can find that this is secant squared of x. Now, a similar argument can be made for cotangent, but I'm not going to do it here. Or, sorry, not. Wait. Yeah, sorry. So, the derivative of cotangent of x is equal to negative cosecant squared of x. So, if you notice, they come in like patterns and opposites. So the derivative of tangent is secant squared. Derivative of cotangent is negative secant squared. Cosecant squared. Alright, so the derivative of the derivative of cotangent of x is equal to negative cosecant squared of x. Alright, so now we're going to do some practice. So, the derivative of 3 sine of x minus cosine of x. We know that sine differentiates to cosine, so this becomes 3 cosine of x. And then cosine differentiates to minus sine, so the minuses will cancel and we'll just get plus sine x. Alright, for this one, we're going to need a little bit of chain rule. So our outside function is tangent of x, and our inside function is 6x minus 5. So, we're going to do the derivative of the outside evaluated at the inside, all times derivative of the inside. So let me just write. Let's say this is f, that's our outside, and our inside is g. This is going to be f prime of g, all times g prime. So we know that the derivative of tangent is secant squared. So secant squared of 6x minus 5. the derivative of 6x minus 5 is just 6. So this is 6 secant squared of 6x minus 5. For the second one, let's split this up. So the derivative of secant, we know that is tangent times secant, or secant times tangent. So this is secant x tangent of x plus, now the derivative of cotangent is negative cosecant squared. But we have a chain rule. So our inside function is, let's call it g. Our outside function is f. So this would be f prime of g times g prime. So we know the derivative of f. We know f prime is going to be negative cosecant squared. And then g prime is just 2. Okay. So we take f prime of g. That's plus negative cosecant squared of 2x. The whole thing times g prime. Or this whole term times g prime. So times 2. So that's secant of x, tangent of x. And then we have a minus 2 cosecant squared of 2x. Alright, so there are 2 more problems that I'm going to go through. So for this first one, we have e to the cosine of x squared. So we kind of have to use chain rule 2 times. So we have an outermost function that's e to the x. So that's f. And then let's call this function g. That's our inner function for now. So using our chain rule, this is going to be f prime of g times g prime. Now f prime is, so our function is e to the x, so that's just going to be e to the x. So f prime g, that's e to the cosine of x squared times, we want to know the derivative of cosine of x squared. So again, I'm not going to write it out, but the derivative of cosine of x squared, we need a chain rule. So this is e to the cosine of x squared times, okay, so the derivative of cosine, we know that's minus sine, and then we have of x squared times the derivative of the inside, that's 2x. So all in all, this becomes, how do I write this? 2x e to the cosine of x squared. Or actually, I want that minus up in front. Minus 2x e to the cosine of x squared sine of x squared. Alright, for this next one, it's a bit more, I guess, straightforward. We don't need chain rule 2 times. So our outside function is sine. So we do cosine, because that's the derivative of sine, of the inside. So square root x minus 5 cosine of x times the derivative of the inside. So we do these 2 parts of the inside separately. So the derivative of square root of x, that's the derivative of x to the 1/2. So this is 1/2 x to the minus 1/2, if we use our power rule. X to the minus 1/2, that's 1 over square root x. So all in all, this becomes 1 over 2 root x. Oh, and then we have a minus 5 cosine of x. Cosine of x differentiates to minus sine, and then the minuses will cancel, so we have a plus 5 sine of x. And that is our derivative. Alright, thank you for watching. I hope that video was helpful. In the next video, I'll do some inverse trig derivatives, and then after that, I will do some hyperbolic trig derivatives. So I hope that you have a good rest of your day, and thank you for watching.